Welcome to today's ArXiv CS Digest for May 18th, 2026. We received 932 new computer science papers today across 62 subfields. Let's dive into the top picks. Trend 1 of 10, Fundamental ML Algorithms and Theory. This trend explores the theoretical foundations, properties, and performance limits of core machine learning algorithms and models. This cluster covers 130 papers. Representative work includes Surge, approximation-free, training-free particle filter for diffusion surrogate. Deep sequence models tend to memorize geometrically. It is unclear why, and general preference reinforcement learning. Trend 2 of 10, Generative Vision and 3D Understanding. This trend advances generative models for 3D scene understanding, reconstruction, and controllable synthesis, ensuring consistency and quality. This cluster covers 98 papers. Representative work includes Can These Views Be One Scene? Evaluating multi-view 3D consistency when 3D foundation models hallucinate. Spectral progressive diffusion for efficient image and video generation. And PXL relight, controllable relighting via intrinsic conditioning. Trend 3 of 10, LLM inference, reasoning, and optimization. This trend unifies efforts to optimize LLM inference and reasoning, boosting efficiency, performance, and practical utility. This cluster covers 117 papers. Representative work includes predictable confabulations, factual recall by LLM scales with model size and topic frequency, early stopping chain of thoughts in large language models, and democratizing large-scale reoptimization with LLM-guided model patches. Trend 4 of 10, parallel computing and system optimization. This trend investigates optimizing system performance and resource utilization through parallel and distributed computing techniques. This cluster covers 65 papers. Representative work includes a readiness-driven runtime for pipeline parallel training under runtime variability, ranking opinions with few states and population protocols, and POPI, opportunistically exploiting parallelism in Python compound AI applications. Trend 5 of 10, developing and benchmarking AI agents. This trend focuses on developing and benchmarking AI agents for autonomous task execution and interaction across diverse environments and tools. This cluster covers 82 papers. Representative work includes Code as Agent Harness, OS World Human, benchmarking the efficiency of computer use agents, and RoboCortex, a self-evolving embodied agent via dual-grain cognitive memory and autonomous knowledge induction. Trend 6 of 10, ML for specialized data and tasks. This trend advances machine learning techniques for processing specialized data types and addressing domain-specific challenges. This cluster covers 93 papers. Representative work includes Attention, differentiable and adaptive sparse hierarchical attention, waveflow, audio generation and waveform space, and BioLip, language generalizable lip-sync deepfake detection via biomechanical constraint violation modeling. Trend 7 of 10, Dexterous Robotics and Embodied AI. This trend focuses on equipping embodied AI systems with advanced dexterity and intelligence for complex physical world interaction. This cluster covers 64 papers. Representative work includes ESI Bench, towards embodied spatial intelligence that closes the perception action loop, actionable world representation, and Dex Hold'em, playing Texas Hold'em with Dexterous Embodied System. Trend 8 of 10, AI Safety, Ethics, and Trust. This trend unifies research on ensuring AI safety, ethical deployment, and trustworthiness by addressing robustness, reliability, and mitigating vulnerabilities in AI systems. This cluster covers 85 papers. Representative work includes Traditional statistical representations outperform generative AI in identifying expert peer reviewers. What is the AI doctor value? Auditing pluralism in the clinical ethics of language models, and LLM-Safety evaluations lack robustness. Trend 9 of 10, Video AI, Agents, and Multimodality. This trend leverages AI agents and multimodal learning to create, understand, and interact with video content. This cluster covers 103 papers. Representative work includes Aurora, unified video editing with a tool using agent Vision OPD, learning to see fine details from multimodal LLMs via on-policy self-distillation, and LongLive 2.0, an NVFP4 parallel infrastructure for long video generation. Trend 10 of 10, Interdisciplinary ML and Foundations. This trend explores fundamental ML theory and its interdisciplinary applications across diverse scientific and computational domains. This cluster covers 95 papers. Representative work includes efficient and accurate graph classification with hyperdimensional computing on FPGA, global training, and the collaborative structure of elite U.S. science, and neural networks with dense weights are not universal approximators. Up next, our first paper out of 10, LLM-Safety Evaluations Lack Robustness by Tim Bayer and Stefan Giunman from Technical University of Munich. Let's break down its key contributions. The authors systematically analyze the entire LLM-Safety evaluation pipeline, examining stages from dataset curation to response evaluation using LLM judges. This comprehensive review helps to understand the current state of safety research. This contribution focuses on identifying key issues within each stage of the LLM-Safety evaluation pipeline. The authors highlight the practical impact of these problems, which often stem from noise sources like small datasets and methodological inconsistencies. The authors propose a set of practical guidelines designed to reduce noise and bias in future evaluations of attack and defense papers. These guidelines aim to improve the robustness and comparability of research results. This paper also offers an opposing perspective, highlighting the practical reasons behind the existing limitations in LLM safety evaluations. This balanced view acknowledges the challenges faced by researchers in the field. Up next, our second paper out of 10, Mapping Human Anti-Collusion Mechanisms to Multi-Agent AI Systems by Jamiu Idu and Ayman Alfahid from Sahel AI, Sahel Group Incorporated. Let's break down its key contributions. The authors introduce a detailed taxonomy of human anti-collusion mechanisms, encompassing strategies like sanctions, monitoring, and market design, providing a structured understanding of these concepts. This contribution focuses on systematically mapping these established human anti-collusion mechanisms to potential interventions specifically designed for multi-agent AI systems. For each identified anti-collusion mechanism, the paper proposes concrete implementation approaches, offering practical guidance for integrating these strategies into AI systems. The authors highlight several critical open challenges in this domain, such as the attribution problem and identity fluidity, which are crucial for future research and development. Up next, our third paper out of 10, SwitchPatch, Physical Adversarial Attack Strategy with Switchable Adversarial Objectives by Physical Adversarial Attack Strategy and Tianwei Zhang from Hong Kong University of Science and Technology. Let's break down its key contributions. The authors introduce SwitchPatch, a novel physical adversarial patch that remains static yet enables dynamic and controllable attack outcomes based on real-time scenarios. This system overcomes the rigidity of previous methods by allowing attackers to seamlessly switch between attack goals without needing to regenerate or redeploy the patch. This contribution focuses on the innovative mechanism SwitchPatch employs, where attackers can alter predefined conditions, such as projecting different natural color lights onto the patch, to dynamically change its adversarial objective. This method significantly reduces the cost and complexity associated with traditional adversarial attacks. The system leverages its unique design to offer significant practical advantages, as it eliminates the need for regeneration or redeployment for different objectives. Furthermore, SwitchPatch enhances stealth by remaining benign when the specific enabling conditions for an attack are not present. The authors conduct a comprehensive evaluation of SwitchPatch, including theoretical analysis, simulation-based experiments, and robust outdoor tests using an unmanned ground vehicle. This rigorous validation demonstrates the patch's feasibility, effectiveness, and transferability in real-world physical environments. Up next, our fourth paper out of 10, NanoQuant, Efficient Sub-1-Bit Quantization of Large Language Models by Hai-Ken Chung and Minseep Choi from Samsung Research. Let's break down its key contributions. The authors introduce NanoQuant, which is the very first post-training quantization method specifically designed to compress large language models down to both binary and even sub-1-bit levels. This contribution focuses on how NanoQuant redefines quantization by formulating it as a low-rank binary factorization problem, effectively compressing full-precision weights into low-rank binary matrices and scales. The system leverages an efficient alternating direction method of multipliers, ADMM, to precisely initialize latent binary matrices and scales, followed by a block and model reconstruction process to fine-tune these parameters. NanoQuant establishes a new Pareto frontier in low-memory post-training quantization, achieving state-of-the-art accuracy and making large-scale LLM deployment feasible on consumer hardware. Up next, our fifth paper out of 10, Pointwise Generalization in Deep Neural Networks by Xiaojia Li and Yunbei Su from National University of Singapore. Let's break down its key contributions. The authors introduce a novel pointwise generalization theory specifically for fully connected networks, which helps answer the fundamental question of why deep neural networks generalize effectively. This framework resolves long-standing barriers in characterizing the complex nonlinear feature learning regime, thereby building a new statistical foundation for representation learning. The authors characterize the hypothesis for each trained model by introducing a pointwise Riemannian dimension, which is derived from the eigenvalues of the learned feature representations across different layers. The system leverages these new bounds to offer a systematic upgrade over previous approaches, providing guarantees that are orders of magnitude tighter in both theoretical analysis and experimental results. Empirically, the pointwise Riemannian dimension demonstrates substantial feature compression, shows a decrease with increased overparameterization. Up next, our sixth paper out of 10, Necessary and Sufficient Conditions for Universality of Kolmogorov-Arnold Networks by Vyugar E. Ismailov. Let's break down its key contributions. The authors demonstrate that deep Kolmogorov-Arnold networks achieve universal approximation if just one non-affine continuous function is used alongside affine functions. This finding establishes a minimal requirement for KN universality. This contribution highlights a stricter condition for KNs with exactly two hidden layers, showing that universality is achieved if and only if the fixed continuous function $sigma$ is non-polynomial. It differentiates the requirements based on network depth. The authors reveal that the full class of affine functions is not necessary for universality. A finite set of affine functions can replace it. Specifically, for non-polynomial cases, a fixed family of 5 affine functions is enough for arbitrary depth KNs. This contribution confirms that KNs utilizing the spline-based edge parameterization, as proposed by Liu et al., are universal approximators in the classical sense. Up next, our seventh paper out of 10, Hardware-Software Co-Design of Scalable, Energy-Efficient Analog Recurrent Computations by Arthur Fionn and Guillaume Drian from University of Liège. Let's break down its key contributions. The authors demonstrate that hardware-software co-design can overcome the long-standing challenge of noise accumulation in analog recurrent computations, which previously limited analog implementations to feed-forward architectures. This contribution introduces an ultra-low power current mode analog implementation of bistable memory recurrent units, BMRUs, designed from first principles, where each learned parameter directly corresponds to a circuit element. The discrete outputs of BMRUs are key, suppressing analog noise by at least 20-fold at each cell boundary. The system leverages a reformulation of BMRUs for first quadrant operation with fixed thresholds, which enables the direct parameter-to-circuit correspondence while maintaining the network's expressivity and trainability. The authors establish a near-perfect agreement between software predictions and circuit-level behavior through transistor-level simulations, allowing the software model to serve as a high-fidelity simulator for the physical hardware at low computational cost. This work reveals that the power cost of adding recurrence scales linearly with state dimension, a significant finding given that feed-forward layers typically scale quadratically, meaning recurrence can be integrated with a linear marginal cost relative to the feed-forward backbone. The system achieves sub-microwatt inference for end-to-end keyword spotting. Up next, our eighth paper out of 10, Ethical Hypervelocity, EHV Approvably Deterministic Governance-Aware JIT Compiler Architecture for Agentic Systems by Riddhi Mohan Sharma from IEEE. Let's break down its key contributions. The authors introduce Ethical Hypervelocity, EHV, a novel architectural framework designed for the formal verification of AI governance policies directly at runtime. This system addresses the critical safety gap in autonomous agentic systems by providing hardware-rooted enforcement for high-frequency policy updates. This contribution focuses on relocating the policy enforcement point, PEP, directly into the inference pipeline through a specialized governance-aware, just-in-time JIT compiler. This innovative approach significantly reduces the latency associated with traditional retrospective auditing frameworks. The system leverages conflict-free replicated data types, CRDTs, for policy synchronization and epoch-based attestation, caching within trusted execution environments, TEs, to achieve sub-millisecond formal determinism, SMFD. This ensures extremely rapid and reliable policy enforcement. The authors formally verify, using TLA+, that non-compliant agentic actions are computationally unreachable within the system's bounded operating state space. They prove that 1. Runtime enforcement eliminates the traditional trade-off between deployment velocity and governance integrity, drastically reducing governance latency. Up next, our 9th paper out of 10, LLM-based static verification of code against natural language requirements, an industrial experience report by Ji-Quan Zhou and Songyu Chun from Neo Incorporated. Let's break down its key contributions. The authors introduce a novel two-stage LLM-based workflow designed to statically verify implemented code against natural language requirements. This system addresses the challenging problem of ensuring code behavior matches intended business logic without relying on execution. This contribution focuses on an AI-based rule miner that intelligently extracts verifiable rules directly from natural language requirements. It also explicitly identifies ambiguities, contradictions, and non-verifiable statements within those requirements, improving clarity. The system leverages a structured intermediate representation to significantly enhance the reliability of LLM-based verification. This crucial step helps mitigate common LLM issues, such as hallucination, output variability, limited explainability, and context loss during the verification process. The authors present a new form of requirement-aware and semantics-aware static analysis that complements traditional software testing. This method shifts verification and validation activities earlier in the development lifecycle by analyzing requirements and source code without needing compilation or runtime environments. Up next, our 10th paper out of 10, Oscar, Offline Spectral Covariance-Aware Rotation for 2-bit KV Cache Quantization by Zhongzhu Zhou and Xiaoxiao Wu from Together AI. Let's break down its key contributions. The authors introduce Oscar, an innovative ultra-low-bit KV cache quantization method. This system estimates attention-aware covariance structures offline, then uses them to derive fixed rotations and clipping thresholds, which effectively aligns KV quantization with the covariance structures that attention actually consumes. This contribution highlights the development of a fully deployable Oscar system, featuring a custom INT2 attention kernel. The system is designed to be compatible with Page KV cache, serving, and Fuse kernel pipelines, allowing for seamless integration into modern LLM serving frameworks like SGLang and VLLM. The system achieves drastically improved accuracy for INT2 KV cache quantization, significantly narrowing the BF16 accuracy gap on various reasoning models. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.